Clean, safe water is the foundation of our daily lives. In Malaysia, every drop from the tap has been on an extraordinary journey. It's drawn from raw water sources like rivers, then undergoes a rigorous engineering process, coagulation, sedimentation, filtration, disinfection, before becoming reliable drinking water. But on the evening of January 14, 2025, Sungai Kabel at Baranang turned into this. The river had turned pink along a 500-meter stretch. News of a pink river instantly trended locally. Lewis's emergency team rushed to the scene. On site, rapid testing devices hummed with readings. Each sample collected aimed to answer the critical questions. What's in it? And where did it come from? Lewis's initial investigation pinpointed the source: a plastic recycling factory in the Baranang industrial area. The factory admitted to an accidental release of processed effluent that night. Faulty infrastructure allowed untreated wastewater into storm drains, flowing into Sungai Kabel. So what's actually in this pink effluent? Final analysis is pending, but the plastic recycling industry suggests it contains industrial dyes and pigments, the direct agents of the color change, toxic plastic additives like plasticizers and stabilizers, microplastic particles, possibly surfactants from cleaning processes, and heavy metals that could come from plastic pigments or factory equipment. When pollution breaches our defenses, it triggers a chain reaction impacting us all. First, water treatment plants bear the brunt. Pollutants like those in Sungai Kabel require longer retention, can instantly exceed design limits, disrupt processes, leading to severely non-compliant treated water. Crisis response forces plants to use massive, costly extra chemicals like special coagulants and activated carbon. Equipment such as filters and pumps overworks, maintenance frequency and costs soar. Worse, toxic sludge volume multiplies, requiring expensive disposal. In nature, pollution causes direct, acute toxicity, leading to mass aquatic life kills. It coats and suffocates plants, destroys spawning grounds and habitats. Pollution-sensitive species vanish first, collapsing the river's ecological web and biodiversity. Ultimately, the threat returns to us. Pollution greatly increases outbreaks of waterborne diseases like typhoid and cholera. More insidiously, pollutants like heavy metals and certain plastic additives bioaccumulate in fish, entering our food chain. Long-term exposure can lead to cancer, developmental issues, or neurological damage, harming generations. Confronting complex industrial effluent like Sungai Kabels requires more than conventional methods. It demands a purpose-built, multi-stage deep treatment system. Here is the engineering solution: a plant integrating advanced physical-chemical treatment, biological filtration and aquatic treatment and monitoring. Stage 1 is primary screening and grit removal. Install rotary drum screen about 1 mm to 10 mm to capture large plastic fragments and a sand catcher to remove inorganic grit. Then, the wasted will send to Zone A, which is advanced physical-chemical treatment. First of all, the wasted will undergo advanced oxidation processes, AOPs. Since the water in Sungai Kabel turned pink, simple filtration won't suffice. AOPs such as Fenton's reagent or UV/ozone to break down the complex organic molecules responsible for the pigment. This unzips the chemical bonds of the dye, making it colorless and biodegradable. Next, instead of just adding chemicals which create more sludge, electrocoagulation, EC, uses electrical current to destabilize pollutants, which is particularly effective for removing the fine plastic particles and pigments found in recycling effluent. Zone A also will have real-time spectrophotometry. Install sensors capable of detecting specific wavelengths associated with the pink dye. If the absorbance levels rise above a threshold, a PLC, programmable logic controller, would instantly divert the flow to an emergency holding tank, EHT. After that, the wasted will pass to Zone B, which is biological and filtration treatment. Moving bed biofilm reactors, MBBR, enablers of higher treatment efficiency and smaller footprints. In an MBBR, they have millions of tiny plastic surfaces to cling to, which allows for a much higher concentration of bacteria in a much smaller tank. The next part is the reverse osmosis unit, RO. Reverse osmosis, RO, is the superfilter of a wastewater treatment plant. While regular filters catch sand or dirt, RO works at a molecular level to remove dissolved chemicals, salts, and even the smallest pigment particles that cause the pink color in the river. In our solution, we will add on a vacuum evaporator. A vacuum evaporator is an advanced wastewater treatment system that separates water from contaminants by boiling the liquid at a much lower temperature than normal, around 30 degrees Celsius to 40 degrees Celsius. The pink dye molecules in the solution cannot evaporate. They stay at the bottom, only pure water vapor rises. Then we'll move to Zone C, aquatic treatment. This is the guard zone. Its job is to ensure that the high-tech cleaning done in Zones A and B actually worked before the water touches the environment. At this zone, an AI monitoring system will be installed to measure pH, turbidity, and COD in real time. To enhance our treatment system, we also have nature-based solutions, NBS, as a final buffer in Zone C. After technical treatment, the water could pass through a small engineered wetland before reaching Sungay Cobble. Plants like Phragmites or Typha provide a final polishing step, absorbing residual nutrients and providing a visual green indicator of water health. Our solution first paints environmental revival. Short-term, it halts pollution and reduces acute harm. Long-term, the river regains life, with full ecological functions restored. What unfolds next is economic resilience and savings. Despite upfront investment, in the long run, it drastically reduces massive plant operation costs and public health expenses. More crucially, it steadily nourishes agriculture, fisheries, tourism, and the entire community economy, completely avoiding water crises and colossal losses. The scroll concludes with social health and justice. Beginning with raised community awareness, it ultimately secures a most basic human right, safe water for all. It directly reduces the societal disease burden, enhances public well-being and productivity. In Malaysia, clean water is fundamental, yet our raw water sources face constant and widespread threats. From peninsular to East Malaysia, from industrial heartlands to agricultural basins, alarms for raw water contamination are sounding everywhere. From DOE, Department of Environment Malaysia, of the 672 major rivers monitored nationwide, 475, 71%, were classified as clean, 170, 25%, as slightly polluted, and 27, 4%, as polluted. The data doesn't lie. Our fragile rivers are sending a collective distress call. Precisely because the challenge is vast and widespread, the power of every single one of us becomes more crucial than ever. The real change starts with each person's choices and actions. You have the power to make a difference. Protect our waters, secure our future.